Welcome, everyone. Hello to lesson 9 this time of Full Stack Bootcamp. And today I will try to give a lesson about testing. All you need to know about testing, basically. It's not the most easy topic considered in general, but it's really not that difficult. I think it's underrated, the topic, and in all the boot camps and in universities, it's definitely undertaught. And that's why I'm teaching it to you today, because in every workplace that is at least somewhat decent, you will be writing tests. Quality is important, and we can ensure that with a nice suite of tests. All right. What will we do today? We will grab the code from before, the shopping list controller, the whole API, and we will test it at least a little bit. Let's get to it. Before we proceed, I would like to show some theory. Why should you care? Is the first question everyone asks themselves. Why should you learn testing? Can't you just manually test your code, click through and see if it works? What's the big fuss about automated tests? Why do you need them? Well, there are many reasons, which I try to put in this section. Tests are fast. No matter how fast you click, you will not click faster than a few milliseconds. That's the speed under which test runs. Tests act as documentation. If you read a test, you will see under which conditions how the function behaves. So, a benefit, once again. Tests give you freedom to change code. Sometimes people are saying, well, I have my tests, I make changes, the tests break, then I have to fix tests, then I have to fix code. That's fine. The whole point of tests is that if you mess something up, those messing ups will be picked up by the tests. So the fact that test failed after you changed something is a good thing because it detected something that might have happened unintentionally and just said, please have a look at me. Please double check. It's important to realize that this is a benefit and not a drawback. If you practice writing tests, you see bugs before actually running your application. You implement something, you run the tests, and here you have it. Something broke or not. So, tests are the first line of defense against bugs. They protect against bugs firsthand before code goes further into more of a life cycle parts. When a test fails, you will see exactly the function that it failed at and the reason why it failed. So, again, super useful. And lastly, compare automated tests to manual testing. You know, when you manually test, you will be clicking and it eventually becomes quite repetitive. Some people call it monkey job. But when you write automated tests, it involves your brain. It makes you think a bit more than manually clicking. In other words, if you want to be a good developer, tests, writing them is a really nice way of going that direction because you are automating things, and automating things is what a developer does. So Write tests, because naturally that just makes you a better developer. And here is a nice diagram comparing the price, the cost it takes fixing a bug in each stage of development. So basically, if the first one is obvious, it costs like 1. It's like the ratio to which all other things are related to, right? So if you realize that you don't need to make something, or that there is a mistake in a document, as you read the requirements, it's the cheapest possible thing, the biggest benefit ever that you can do. If you spot a bug in requirements, it's cheap. Fixing it is cheap because you won't do any coding. It's just reading. So read through carefully. Then in coding, it's unit testing, this one that's meant. And then integration and component testing, you can see layers and layers and layers of testing. And then finally, you have code that's actually released. And if a bug goes through after all that testing, it will cost a lot to fix. It will cost a lot to fix because first, the customer will complain. The customer might not give you the logs. You might not have access to them. The customer might fail to explain what went wrong, but there is a problem nevertheless. In fact, the customer might even refuse to communicate with you. They just might complain. So fixing a bug in production is really costly. And the biggest price you might pay is your reputation. In some cases, some major failures might literally ruin the business. So be careful. Test your code, ideally through automated tests. So that's what we'll be doing today. In .NET, we have 3 options for writing tests. What do I mean by those 3 options? There are 3 frameworks for writing tests: xUnit, NUnit, and MS Test. The one that I recommend the least is MS Test, because it is the slowest, the most tedious to work with, and doesn't really offer anything of its own. So I would suggest not using it. My personal favorite is xUnit because it's very object oriented. But if you want to have something that's most featureful, go for NUnit because it is the oldest one of all. And NUnit was but ever since .NET came out, it had NUnit. It was the first framework coming with it. So therefore, it's the most featureful, richest. If you want a longer comparison of the frameworks, refer to this link, which is in the wiki, which you can find in the description. So let's test our code, shall we? Let's close this window for now. In order to be able to test, you will need to create a test project. So I will create a new project. I'll filter through tests. I'll select xUnit because that's the framework we'll be using for testing. It's my favorite. I will call this shopping list API .tests. .tests is the suffix you give for tests. And I hit create. And you might see some red here, so just build the project and it should succeed. And now we have a test project, But you know what happens to new projects? They don't see code from other projects. So if we want to include the code from other projects, we need to add a reference to it. So right click on dependencies, add project reference, and select the one you want. In our case, shopping list API, because shopping list API tests shopping list API. When you already have a project which has been implemented, writing tests might look like an intimidating task. It's daunting for sure, because where do you even start? As a rule of thumb, I would go from the lowest level stuff that has as few dependencies as possible. So I'll first look at the models. And the first thing that I can see I could test is this fixed tax policy. So I will write a test for it. Best practice is to at least have a test class per a class under test. Let's do it. Fixed tax policy tests. And this one. And this one. So, what are we testing here? We will be testing this method apply, which simply verifies these two numbers, we get the expected number. Basically, we're testing apply method. And it barely has any input. The input doesn't really matter. So we're testing apply method. Note that above this method, we have a weird thing called the fact. So here's the thing. In xUnit, we have facts and theories. Facts are tests which are always true, tests which don't require parameters, and theories depend on a whole bunch of variables. They are parameterized tests. It's like a theory. What happens if I do this? What happens if I do this? What happens if I do that? So facts are always true, and theories depend on different factors. So facts are parameterless tests, theories are tests with parameters. Apply is having always the same behavior. It always multiplies stuff. So let's do it. It's a basic multiplication, so I'm sure that it's easy to get it right. So we need to, every test is a three steps basically. Arrange, act, and assert. In arrange, we set the thing under test up. What are we testing? We're testing fixed tax policy. So I created here, and I specified taxes. It doesn't matter much. I will specify this number because 1 would mean that after I multiply things, they don't change. And 1.1 means that it will change in some way. So my apply will return price after taxes. And that will be when I apply some the policy against some price. And the price is 2, for example. And my assert will say that I assert the price to be equal to expected. So my expected is 2.2, I guess. And if I click run, it runs the test, but you might not see this button. So I will access it from a visible way for you guys as well. If you click test at the top of your screen and select Test Explorer, on the left, it will open a tab for tests view. And here you can run your tests. Here is mine, which ran this piece of test. And as you can see, it's green. It has a check mark, which says test succeeded. This test is bad because it's named poorly. I just said what I'm testing, but I didn't say what is my expectation. So my apply method should return price after taxes. And here I should have specified the price. And here I should have specified taxes. And pass those instead for better clarity. And same for this one. Use constants to escape magic numbers. And now this test is much better, for it is not just a test, but it's also documentation clarifying what do I expect from my method. Perfect. It works. This is a very simple test. Next, let's continue with a more complex one. Progressive tax policy. All right, let's get it done. This one is much more difficult because essentially it's a theory. It depends. The higher the price that I'm paying for something, the bigger the taxes will be. And there are multiple thresholds, and it's quite complex. It should be tested. Last time, we just had a look at it briefly and said, looks all right. But that's not the way you should look at things. You should be more careful. We should have been more careful. And today, we will know for sure if it works as expected or not, because we will write a test for it. All right, so progressive tax policy. Every test class must be public. Otherwise, our test explorer will not recognize this class. Again, I just write placeholder method names because I'm not quite sure how will they turn out until I have written more about the test or looked deeper into code. All right, so we have progressive tax policy. So we create progressive tax policy. tests. I forgot the word tests. Okay, better. Okay. So this is my range. And note that I no longer need to specify comments here. I did that for clarity purposes before as learning purposes, but normally you don't do that. You can do that, sure, but it needs purpose. If your tests are more complex with more parts in them, then sure, you can write arrange, act, assert comments, and that will clarify things. Donut did make a nice remark that member name with a underscore in the end is awful, and I agree because I know that it's not the way to do it, but I'm not done yet, so it's a placeholder reminding me with its hideousness that I should finish that name soon. It will be finished. All right. So progressive, again, we do the same thing. So I'll say what the price will be. Price before taxes will be 2 once again, let's say. And we apply price before taxes, and we get price after taxes. And my assert, I have no idea what my assert will look like. So here I write decimal expected price after taxes. I will write 1, though I have no idea what it will actually be. I will have a peek at this method. So it will be 0. It's under 10, so it will be 0. So if an item is under 2, if it's under 10, so 2 is under 10, that means that the tax policy will not affect it. So it will remain as before. So 2. Great. Or better, so this indicates that it didn't change, right? And this is a fact for now. And thus, if I run this test, which looks awful, and now I should fix it, apply, returns price after progressive taxes. Great. And here's the thing. We use the fact, and we could write a bunch of facts, which I will do for showcasing what I meant. Apply when price under 2 returns price returns unchanged price, because that's what it did. It didn't change the price. And here I could write apply when under 10, I mean, when between 10 and 100 returns price after first taxes. And this will look like, it's actually 20, not 100, sorry, between 10 and 20. And this will be 0.1. So 2.02 is my expectation. Let's run the test. Okay, interesting. Oh, right. It should have been 15. And this will be now 15.015 M. Okay. 15, sorry. Yeah, 15, sorry. Okay, great, it works. Obviously, if you look at these two tests, you can see that the only part that is different is the price before and the expected price after taxes. In other words, these two things are variables, and instead we can move them to variables. So I will do just that. I will create a single theory and test my things instead through that. So the theory will have two inputs, as I mentioned. One is price before taxes, and the other one is expected. Sorry, it's not double, it's decimal. Price before taxes and price after taxes. Decimal because it's money. All right. I'll simply move this in here, and I will remove this because it's an input, and I'll remove this because it's also an input, and this is expected price. Okay, great. Now we need a way of passing input into these parameters. How do we do that? Simple. In xUnit, you can use another argument, attribute, inline data, to pass values to your parameters in test. And in my case, it was 2, and the expected was 2. So if I pass 2, price before taxes, I expect the price to be 2 as well, because it falls under the progressive tax limit. It's actually quite useful to just take this tax range and paste it as a comment here for now, for it provides me invaluable information when is what tax. So 2 and 2, and I no longer need these. So I continue. Here is an important bit. When testing, we should apply edge cases. What happens when it's 10? Does it remain 10 or does it switch to the next tax? It's important to verify this. For now, I assume it's still remaining to the previous one. Next, when it's 10.001, it should become 10.1001. Next, we go to this one. 100 will be 101 because it's 101, the multiplier. Let's add a few more. 100.01 is 100. 1.02 is the multiplier this time. So 102, no, like this, I think. Yeah. Why is it complaining? Oh, dot, not comma. Okay, and I should add letter M everywhere, because otherwise really? Okay, never mind. Okay, this is fine. Next, I'm also missing the edge case of just before that range. So that's 9.9. With 9.9, I get 9.99. And actually, I think it's a bit redundant testing every bit like this. So I will only check just before and just after once, because it follows the same traversal from one range to another. I don't need to do the same thing for every of those, because it follows the same principle. So if I do this for one, it should apply for all. But for individual ranges with individual multipliers, I need to still verify their results. So for 2, which is less than 10, I have 1. For 999, it's still the same. For 10, it's still the same. For 1001, it's already next one. For 100, I will not do it. For 101, it's... I need a calculator now. 101 times 102. Okay. Next, we have 1001. And the multiplier is 1.1. 1.1. Okay. 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 And last one. This one is easy. Well, it's not quite easy. 1 times 2. Okay. Like this. Yes, I know that it copies the line. Oops. But I sometimes forget. Thank you for reminding. Okay, that's basically it for the tests for this one. It covers everything. If I run it, it doesn't work. It fails on those edge cases. So I will make it pass. I want it to be exact, include the edge with the smaller one. So I want, yeah, the policy to be inclusive. Okay, it fixed the edge condition. But we still have some issues. For example, this one. When it's 101, why is it failing? Why is it failing? It should 10.01, 10.01 should have been multiplied by 101. Yes. Like this. 1011. Yeah. Why is my expectation so off? I miscalculated. Okay, so I can fix it. Next, 101. Whoa, okay. Expected. Yeah, I see what I did wrong. I missed one policy altogether, I think. Yeah. I missed this super tax, which is 2. Yep. So everywhere I made a mistake. So I need one more. Okay. Or not. I'm confused. 100? Oh, right. I missed one. Yeah. Okay, makes sense. So this is double. Not here. What am I doing? Oh, it's 2 zeros here, not 1. Wow. I messed myself. Okay. Right. Okay, so this is fine. Let me run the tests quickly. Yes. This will be this one. Sometimes it's okay to fix tests based on their actual output if it makes sense. In our case, it really does. 1.2. Yeah, this was 1.2. Double checking. Yeah, okay. I miscalculate awfully. 101. 1. Okay. Cool. And if we run, This one is that one, and the other one I messed up. Let's build so that it removes those, or rebuild so that it removes those random. It's sometimes annoying that it doesn't remove those that I deleted. Expected 11111, actual 1.2, 12012, yes. Okay, so those are the expectations and they have been verified. I did not check the range on every time because it's pointless. It behaves the same way, so there is no point checking those border conditions every time. I checked them once. Just a bit more and just a bit less. And then exact, and then those that are clearly inside the range. When you're working with decimal numbers, floating point numbers in general, add precision. I will write 4 here as precision for the test case. So 4 decimal places will be checked for a match if my test worked. Anyways, this is a parameterized test. Inline data provides data for those arguments in my test case. Cool. We've just tested another thing. Let's continue. This is testable, but it's a boring test, so we will skip it. Let's look for something more interesting. This is also testable and interesting, but we will not test it due to lack of time. Let's look for something that throws an exception. Great, argument exception. Let's test shopping list service. Once again, I create a new class. It's public, so that tests discover it. And I forgot to say tests. A test class should end with tests. Okay. So public void, I'll just call it test. I don't know what I'm testing. I'm testing a service, shopping list service. So I will create it. Okay, great. And what am I testing again? I'm testing remove shopping list method. And I will need to verify if exception was thrown. So this time our method under test is remove shopping list. And we have a precondition. So given there is no shopping list, or rather given, or rather when non-existing shopping list ID throws argument exception. And now you can clearly see why we use underscores in test names, because they are long. They have to be descriptive, otherwise you don't get the benefit of documentation in them. In any case, the first part is the name under test. The second part is precondition, and let me specify that. That's the non-existing shopping list ID. And that's the throws part. So in these three parts, we made it very clear and distinct under what conditions what happens. Now we need to remove this argument, this comment, and replace it with a proper assert statement. So assert throws is the one we want. We specify through these brackets the exception we're expecting, which is argument exception. And we need to pass an action that is at fault. So action is a variable that allows storing functions as arguments. And I'll call this function, this action, remove non-existing shopping list. And this is how you define an action. And I will pass that action as an argument to a function which asserts whether that call should fail or not. So what happens is that this doesn't really do anything. This is just preparation for calling something. But by putting it here instead of here, I allow myself to separate the three parts of test, which is a great thing. It gives clarity. So it verifies if argument exception is thrown when I'm calling non-existing shopping list. And it's a fact, it's always true. If it's not existing, it will throw. Let's run. And you can see, test passed. Let's continue. Once again, a fact. This time, I'll say remove shopping list, and yeah, I will create a shopping list. With an ID of that existing shopping list. And I will add that shopping list to the service before doing the test. And now I can remove the shopping list that I created. And in fact, it's not an action anymore because this is not a faulty call. This is a workable call. It works. So instead, I just do this. And now all I need to do is to assert whether this works or not. So I'll go and say service get, which returns all shopping lists. And I will make sure that my shopping lists does not contain shopping list to remove. Great. So that's my test. And if I run both, you can see that they both pass. All right. We now have tested three quite distinct things with facts and theories. We tested simple objects and more complex ones. Let's amp the difficulty up a bit and test something that has more complexity in it, a controller. So, let's see what we can do. Let's test a get method and let's test an add item method, I suppose. So these two. All right. Shopping list controller tests is the new test suite class that I will create. And I kind of like having the things I test inside the test as a comment so that I can quickly reference what I'm testing if I'm writing a test after the code. All right. When you're working with a controller usually doesn't do anything by itself, right? Remember what we discussed last time? Controller is made of components. For our test, we need to initialize those components in advance. So I will create those components right here. I don't know what components am I looking at, so I'll go back to a controller and literally copy paste it. Well, not everything, but just those components, because I will be needing them. And I will initialize them. So new tax shopping list converter, new tax policy, doesn't matter, fixed. Okay, we have one. So no taxes basically. Let's go with butter. Shopping list service, we have second. Let's go with third. Items generator. Done. We have the components. Now we can make a test. So public void get when we look for something that does not exist. Once again, we'll do int non-existing shopping list ID. And that's it. If we call not this, but oh right, I didn't create the thing under test. So these are just components. the thing that I'm testing is shopping list controller. So it needs special attention, or it takes all those things. Shopping list service, items generator, and text converter. Here we go. So we have our controller under test. And we call get with ID. And we say that and here's the thing that we will test. We are no longer caring about the actual outcome of the service. After all, we already tested what happens if we pass non-existing ID, right? So what we care about here is simply the fact that it was a bad request or an okay. That's all we care about. If it's non-existing, it's going to be a bad request. So this is an action called get non-existing shopping list. And if I pass that, we expect it to be not to throw an exception. Sorry, my bad. We expect this. Here we go. And that's a fact. If it's something that doesn't exist, it should be bad request. Let's see what it says. Expected bad request, but was not found. Sorry, it was supposed to be not found, not bad request. Yeah. Let's run the test once again. Let's run all tests. Yeah, I am here. So it works. If I passed something that didn't exist, bad request. Not found, sorry. Yeah. What happens if I try to get something that exists? So this one, get when when non-existing shopping list returns not found. Get when existing shopping list returns okay. So let's basically copy this and simply say existing shopping list ID, existing shopping list ID, and we need to set up the scenario that this is indeed existing. So I will need to call a shopping list service and add an item in it. So now when I'm getting a shopping list, when it exists, everything is fine, everything is okay. Also ID. So if I run this test, it failed because it's supposed to be okay, object result, not found. Here we go. And like this, you can go through every endpoint and verify behavior. Also note that this time I did not create those components and controller inside a test, because I know that this controller is made of many methods. And that's why it's wise to use a setup to set all the components up before I even start my test. Every time a test case is run, this controller will be hit. This is not a one-time thing. This is done every time this this test case, individual test case is run. So this initialization will happen 2 times because I have 2 test cases. It's time to do one last thing, a technique from ancient times that only a few practice. But those who practice are really good at what they do, and I would like you guys to learn it as well. So, introducing test-driven development, a technique that all good developers should know, but unfortunately, too few do realize how to do it. Let's do test-driven development for a new part of our service, a controller, I guess. What do we want to do? Let's see. So it would be nice to have a way of getting a shopping list by its name. And I think a name is already a part of a shopping list. Let me check. That's right. Oh, by a shop name. That's right. For now, we only can get a shopping list by ID. Yeah. So what if we wanted to get the shopping list by a name? We would create a new endpoint, right? And let's do all that. That's fine. Let's create an endpoint for a shopping list to get one by name. But let's do so in a test-driven fashion. So we will write a test for code that is yet to exist. We are getting a shopping list by name, but since it's a shopping list controller, it figures just get by name is clear enough. So if we get something that doesn't exist, we actually, don't, we return not found. So let's do that. I'll copy paste because it's similar. Existing shopping list name. Non-existing shopping list name, I meant. This does not exist. Why am I creating a new service here? Oh, I'm in the wrong place. Sorry, guys. I am supposed to be in a controller. Okay, great. Well, okay, let's do this. Let's do this. Okay, so if get by name is the method that I'll be testing, and if it doesn't exist, it throws. It doesn't throw, it returns not found. Notice how this method doesn't exist. And that's the essence of TDD. You first write a test for code that is yet to exist. And a failing test in TDD simply means a test that cannot compile. If I try to build this test project, as you can see, it fails. So I need to go into that controller and add that endpoint. And I will. So get by name takes a name. It points to this, I guess. Sure, let's say. And we will be calling shopping list service get we'll go here and implement a method to get by name. For each shopping list, if shopping list shop name is pullover is equal to name to lower, then return that shopping list. Else, well, there can be many of them, right? Okay. What's wrong? Shopping lists, shopping list, shopping lists. That's what I meant, okay? Else we return, well, in any case, we return this. Great. Yes, so I need to change this to IEnumerable. And go back. And by implementing that code, maybe I realized that, well, It doesn't really have to be not found. It can be okay regardless. So regardless of what I execute, I should be getting okays. So let's go back. Okay. Returns okay. And I'll write one more. When existing name also returns okay. All right. So don't do this yet. First, run the test and make sure it passes, which in my case it did not yet. I need to call get by name. Run the test, make sure it passes. It doesn't yet. So this, I need to return shopping lists. And okay, shopping lists. And that's pretty much it. Run the test and make sure it passes. So I run the tests and you can see how it passes. It works, hurrah! Let's make one more test. And this time it will be a theory where I pass multiple different names. So for those inline datas, one name will be existing, for example. So I don't care about ID, but I do care about shop name. And that's the existing shop name. And now I'll play around with capitalization. If it's exact match, it should work. If it's not exact match, it should still work. So we have three cases. All that should be passing. And get by name. It should be okay, object result. The lesson is about to end. It's usually no more than 1.5 hours. And as you can see, the test passes. And that's TDD. The essence of TDD is basically going through a loop of writing a test, writing just enough code to pass that test, refactoring it so that it's pretty, and then making sure that it still works afterwards. That's pretty much it. There are more tests than just unit tests, as you can see in this pyramid. And I wrote a little chart summarizing each. So you also have smoke tests, which just see if code works roughly, if it is able to respond. That's all smoke test does. It doesn't take details in consideration. It just verifies happy path and whether a system can respond successfully. Integration testing is testing multiple components in unison. Actually, the tests that we did here for shopping list controller are integration tests because they depend on 3 other components. So it's an integration test. On second thought, fixed tax policy and progressive tax policy tests are unit tests because this thing has no dependencies. And only later on in future lessons we'll learn how to escape those component dependencies. But for now, what you know is already a lot and enough for you to be fully able to do testing in general and automate your stuff, your tests. So we have system test and nest, and system test would basically require the whole API to be bootstrapped and testing a service, just like we did from Postman, whether it returns with correct responses. So it's testing everything in unison, the whole system. Regression testing is the kind of test that you would repetitively apply as a QA person after a certain change was made in the system. So you wouldn't test parts that are already working, but you would focus only on the related parts in the system. And that's regression testing. Performance and load testing is, as the name suggests, is whether your system can withstand a certain load, for example, gigabytes of data, or if it can respond in milliseconds, or it doesn't consume more RAM than it should. That's what performance tests are testing. And user acceptance tests are just whether user likes what you did, whether it's usable, how easily is the system to use. It also includes UI tests, which I personally haven't written ever. UI tests are necessary, but I'm a backend developer, so I usually don't concern myself with it, even though I probably should. That's pretty much all I wanted to talk about in this lesson. The power of tests, and I hope that you will make use of this power. In the wiki, you will see a few more examples, especially an example of a TDD kind of approach. And a homework, like always, with questions before you finish the lesson and see if you know or not. Learn the topic, if you learn the topic or not. In any case, write tests because they speed our work, because they give trust whether the code works, because they give clarity to the code you wrote. Write tests and be happy that what you did was high quality and is verified. Thank you for watching this lesson and see you in the next one on next Sunday. Bye.